Hello viewers, in today's class we are going to solve yet another important problem from definite integrals, right? So here we have to solve this problem from this integral, that is from 0 to pi by 2 square root of 1 plus 4 cos square 2x minus 4 cos 2x dx, right? So here we have written here the definite integral of absolute value function. So when we'll proceed further, we'll see that this integral will reduce to a problem of definite integrals of absolute value function, right? So let us start, and here if we closely look at this integrand, then we see that the term which is inside the square root sign can be expressed as a perfect square, right? See, here we have 1 plus 4 cos square 2x minus 4 cos 2x. It can be written as 1 square plus 2 cos 2x whole square. Then we have 2 times 1 times 2 cos 2x, right? So this term can be written as a square plus b square minus 2ab. This is a square plus b square minus 2ab, right? And we can write it as b minus a whole square. That is, we can take this term first, that is 2 cos 2x. So we have 2 cos 2x minus 1 whole square, right? So now this integral I can now be written as integral from 0 to pi by 2, and here we have square root of 2 cos 2x minus 1 whole square, right? And here we have dx, right? So now we see that this integrand is reduced to square root of 2 cos 2x minus 1 square, and here we'll make use of the definition of absolute value function, right? And we know that if we have square root of y square, then square root of y square is equal to the absolute value of y, right? And absolute value of y can be written as plus y whenever y is greater than or equal to 0, and minus y whenever y is less than 0, right? So always remember that square root of y square is equal to mod of y, right? So here if we replace y by 2 cos 2x minus 1, then we see that this integral can now be written as 0 to pi by 2, and here we have mod of 2 cos 2x minus 1 dx, right? So viewers, here what we have seen, the term which is inside the square root sign, it has been converted into a perfect square, and then utilizing this result we have expressed the original integral as an integral of mod function, right? So now we have to find the value of this integral. Now before proceeding further, let us first find out the critical points of this 2 cos 2x minus 1 is equal to 0, right? So what we will do, we'll solve this expression equal to 0, right? So we have 2 cos 2x is equal to 1, so we have cos 2x is equal to half, right? And we know that cos pi by 3, that is cos 60 degrees, is equal to half. So we have 2x is equal to 2n pi plus minus pi over 3, right? So this is the general solution of an equation of the type, that is cos x equal to cos, say, alpha, right? If we have a trigonometric equation like this, then the solution is given by x equal to 2 0 and pi plus minus alpha, right? So here alpha is pi over 3, and for x we have 2x, right? Now dividing both sides by 2, we have n pi plus minus pi over 6, right? So this is the general solution of this trigonometric equation, and here n is an integer, right? Now if we take the value of n is equal to 0, then we have x is equal to plus minus pi by 6, and if we take say n is equal to 1, then we have x is equal to here we have pi plus pi over 6, then we have 7 pi over 6, and if we take the negative sign, then we have 5 pi by 6. And similarly we can find out the other solutions, but we are not interested in all the solutions of this trigonometric equation, because here the limits of integration are from 0 to pi by 2, right? And out of these solutions, only x is equal to pi by 6, it lies between 0 and pi by 2, right? And all other solutions will lie outside this interval, that is from 0 to pi by 2. So we'll consider only x is equal to pi by 6, and here when we integrate, or we find the integrals of absolute value function, we see that these points are required to break the limit. So here x is equal to pi by 6 is the point where we will break the limit, and will here we'll have two integrals. One is from 0 to pi by 6, and the other is from pi by 6 to pi by 2, right? Because here we have the absolute value of 2 cos 2x minus 1. So we'll split this I as a sum of two integrals, right? So now viewers, from this result, we can see that whenever x belongs to, or x lies between 0 and pi by 6, then we have the value of this expression, that is 2 cos 2x minus 1, is always greater than or equal to 0, right? The value of this function, that is 2 cos 2x minus 1, is always greater than or equal to 0 whenever x lies between 0 and pi by 6. We can take any particular value of x between 0 and pi by 6, and we can easily verify that 2 cos 2x minus 1 is a positive quantity in this interval, right? And similarly, when x lies between pi by 6 and pi by 2, then the value of 2 cos 2x minus 1 is less than 0, or in other words, we can say that when x lies between pi by 6 and pi by 2, then 2 cos 2x minus 1 is a negative quantity. Now viewers, here we are claiming that when x lies between 0 and pi by 6, then the expression 2 cos 2x minus 1 is greater than 0, or this is a positive quantity. And when x lies between pi by 6 and pi by 2, then 2 cos 2x minus 1 is less than 0, or a negative quantity, right? We can also verify these two results, and this is a simple exercise in trigonometry, but here just for the sake of understanding, let us take a particular value of x between these two intervals, right? So here let us take x is equal to 15 degrees, right? Because here 15 degrees lies between 0 and pi by 6, and let us decide the sign of this quantity. So we have 2 cos 2x, so x is 15, so here we have 30 minus 1, and cos 30 is root 3 over 2, and here we have minus 1, so 2 and 2 get cancelled, so we are left with root 3 minus 1, and this is obviously a positive quantity because root 3 is 1.73 approximately, right? So this is how we can prove that when x lies between 0 and pi by 6, this quantity is a positive quantity. Now let us come to this one, and here let us take the value of x as say pi by 4, that is 45 degrees, right? So 2 cos 2x, so x is 45, so here we have 90 degrees minus 1, and cos 90 is 0 minus 1, so we have 0 minus 1, that is minus 1. So obviously this is a negative quantity, that is less than 0, right? So now this absolute value function, that is mod of 2 cos 2x minus 1 can be written as positive 2 cos 2x minus 1 whenever x lies in the interval that is 0 to pi by 6, right? And here this mod of 2 cos 2x minus 1 is equal to negative 2 cos 2x minus 1 whenever x belongs to this interval, that is pi by 6 to pi by 2, right? So here this interval can also be expressed like this, and this interval can also be written like this, right? So now we can write this integral I as a sum of two integrals, that is I1 and I2. So now I can be written as I1 is from 0 to pi by 6, and C when x is from 0 to pi by 6, then mod of 2 cos 2x minus 1 is positive 2 cos 2x minus 1, and here we have dx, right? And I2 is from pi by 6 to pi by 2, and when x lies between pi by 6 and pi by 2, then we have mod of 2 cos 2x minus 1 is equal to negative 2 cos 2x minus 1, and here we have dx, right? Now the integral of cos 2x is a half sine 2x, and the integral of 1 dx is simply x, and the limits of integration are from 0 to pi by 6. And here this negative 1, we multiply it these two terms by this negative sign, so we have minus 2 times the integral of cos 2x is half sine 2x, and then here we have plus, so integral of 1 dx is x, and we have the limits of integration from pi by 6 to pi by 2, right? So now we can write this expression as 2 and 2 get cancelled, so we have sine 2x minus x 0 to pi by 6, and here we have 2 get cancelled, we have minus sine 2x plus x, and limits are from pi by 6 to pi by 2, right? Now we'll simply substitute the limits and we'll take the difference. So we have sine here x is pi by 6, so we have pi by 3, then we have pi by 6 here, and when we take x equal to 0 over here, sine 0 is 0 and x is 0, right? And here when we take x is pi by 2, then we have minus sine pi, because 2 and 2 get cancelled, and here we have pi over 2, and minus then we have here x equal to pi by 6, so we have minus sine pi over that is 2 3s are, so we have minus sine pi over 3 plus pi over 6, right? So now we can easily simplify this expression. So this is sine pi over 3, that is root 3 over 2, and here we have pi over 6. This is 0, here this is 0, and we have simply pi over 2, and here we have minus root 3 over 2, and this is pi over 6, right? And this is root 3 over 2, this is minus pi over 6 plus pi over 2 plus root 3 over 2 and minus pi over 6, right? And root 3 over 2 plus root 3 over 2 is simply root 3, and minus pi by 6, and minus pi by 6 is minus pi by 3, and here we have pi over 2, and this is root 3, and if we subtract these two quantities, we'll have pi over 6, right, which can also be written as pi plus 6 root 3 over 6, right? So viewers, the value of this integral is given by pi plus 6 times square root of 3 divided by 6.